In this video, you will see the construction process for a concrete block abutment timber deck bridge installation.
All these projects are replacing failed and failing culverts, and a lot of them which were perched, which were blocking fish passage with bridges. A lot of these culverts are starting to fail and they're starting to plug from the upstream end. And for 25 years, the streams up above haven't been used for spawning habitat. And so sort of now we get a chance to kill two birds with one stone, so to speak, by not only removing those failing structures that are a long-term maintenance cost for us, but also opening up spawning habitat that hasn't been used for 25 years.
This type of construction consists of non-reinforced concrete block abutments, steel or timber girders, and timber deck bridge. Typically, this construction can be done with a medium-sized to large excavator. Installation involves site preparation, excavation, and placement of the abutments, girders, and rock stabilization with an excavator. The steel girder assembly can be partially prefabricated prior to delivery to the site to minimize any on-site fabrication. The installation of the timber deck consists of basic carpentry work. A concrete block abutment timber deck bridge is typically used for smaller stream crossings on private land roads or other roads that have a lower traffic volume. Abutment heights are limited to 6 feet for the concrete blocks. Span width openings are typically 20 feet or less. However, up to 40-foot spans are possible using steel girders. These bridges are usually for one lane of traffic. They can be designed for a wide variety of loading requirements depending on the anticipated traffic over the bridge.
We have a lifespan for our practices. In this particular practice, I think it was either aquatic organism passage or stream crossings had the same effect. And both of those, when we have bridges or culverts, we have a 25-year lifespan. Certainly the 25 years here, if anything, all they have to do is replace the deck. The abutments and the steel girders, they should be here. There's no reason they shouldn't be here 50 or 100 years from now.
The steps for this project and all stream-smart road crossing construction projects include the following: a review of the construction plans, water control, on-site preparation prior to construction, initial excavation, setting the abutments and establishing the stream channel, installing the bridge deck, channel shaping and adjacent road backfill. Construction drawings, review plans. Before construction starts, a design needs to be completed that shows enough detail so the bridge can be installed properly. For a bridge, the key components are the location of the bridge, the bottom elevations of the abutments, and the design channel through the bridge, and the bridge opening width or span. This drawing shows a cross-section of the bridge, as well as the elevation of both the bottom of the footings and the design channel elevation through the bridge and the bridge opening width or span. The location of the bridge, in comparison to the location of the existing culvert to be replaced, is also shown. All elevations are established from a benchmark that was set during the initial design survey. The benchmark description is provided on the construction drawings. Other sheets of the construction drawings for this site include specific details for the assembly of the bridge components and the specific requirements for water, erosion, and sediment control. The construction drawings should be provided to and reviewed with the contractor prior to construction. Water control. Water control typically consists of diverting all existing stream flow around the working area of the construction site. Any groundwater encountered in the working area of the site that picks up any sediment or is dirty water is pumped from the site and run through some type of sediment basin before the water is returned to the stream. The bridge was installed in August of 2013 when flows were low. Typically, a cofferdam is constructed both upstream and downstream outside of the anticipated working area of the site. The water pooled behind the upstream cofferdam is pumped around the site back into the stream below the downstream cofferdam. Since flows for this site were so low, an upstream sump with just a minimal cofferdam was needed to pool the stream flow to be pumped around the site. A downstream sump was used to collect any groundwater encountered at the disturbed construction site. Dirty water collected in this sump was pumped into the woods far enough from the stream that the sediments in the disturbed groundwater were filtered out before returning to the stream. For sites where the groundwater flow is higher, a temporary sediment basin may have to be constructed somewhere off-site for the disturbed groundwater to flow through before entering back into the stream below the site. Due to the low surface and groundwater flows during construction, a small pump at both the upstream and downstream sumps were adequate for all water control needed. Scheduling construction at low stream flows is ideal for minimizing the difficulty of water control. Note the fish block nets used to keep fish from entering the work area.
So primarily, we're keeping the clean water clean, and then any of the dirty water, we try to get it clean before we go back into the stream.
On-site preparation prior to construction, delivery of materials. Prior to construction, as many materials and equipment needed for the bridge construction should be brought to the site in order to minimize the time actual construction takes. This is important in order to minimize the time the road has to be closed and can be critical if there are higher stream flows and water control is more challenging. For this site, precast concrete blocks were used for the abutments with steel girders and timber components for the bridge deck. The steel girders were pre-assembled in 2 sections in order to minimize on-site fabrication time. Required earth fill or gravel fill needed for the backfill of the abutments and road construction associated with the bridge should be stockpiled on site as much as possible. There are typically on-site storage limitations. However, stockpiling at least some of the earth fill or gravel fill can save time during the installation, especially if the fill source is a long distance from the site. Construction start, initial excavation. If carefully done, a large portion of the excavation can be done before the water control is initiated, as long as sediments can be kept out of the stream. Here is the pipe prior to the start of excavation. A portion of the road fill over the existing pipe was removed prior to dewatering being initiated. Dewatering was not needed up to this point, as all excavation was kept away from the stream. Here, the dewatering has been initiated since the excavation is getting closer to the stream. All flow through the pipe has been stopped and is now being pumped around the work area. The pipe is left in place to allow for a working area for the excavator to install the far side abutments. This is important as there is only one excavator on site, so all work has to be done from one side. On larger sites, an excavator may be needed on both sides since all of the work area cannot be accessed from one side. Setting the abutments and establishing the stream channel. The excavation for the abutments is dug down to the bottom of the bedding required for the concrete block abutments. Typically, 6 inches of coarse gravel or crushed stone is placed under the abutments for the bedding material, so the excavation has to be dug at least 6 inches below the design elevations of the base of the abutment. Here they are excavating for placing the bedding material and then placement of the bedding material up to the elevation of the base of the abutment. The bedding material should be placed approximately 1 foot wider than the abutment concrete blocks for adequate support. Prior to the final excavation and placement of the bedding material, the final alignment of the abutment is set for the proper place of the bedding material and concrete blocks. Now both abutments are in place along with the rock riprap reinforcement. The channel elevation and shape has also been established. The center of the channel through the bridge is 1 foot higher than the base of the abutments. Placing the base of the abutment 1 foot lower than the design channel bottom and placing the rock riprap reinforcement